I hope you have learned the previous class lessons properly. Ohm's law, its equations, and the experimental verification of the Ohm's law. Now, we have to start with a new topic, that is factors affecting resistance of a wire. Factors affecting resistance. So, we learned the definition for the resistance as the opposition for the flow of the current. So, when current is passing through a material by virtue of its nature opposes the current flowing through it. That property of the material is called as resistance. So, when we come across the resistance, different materials will have different value of resistance. For example, the resistance of copper will not be equal to the resistance of aluminum of same length. That won't be equal to the resistance of another material like a silver. It varies from material to material. But we have to consider certain factors that can alter this resistance. So if you have a wire of L length, imagine you have taken a copper wire of L length. Same copper wire, but if you take another length, for example, if this is 2 centimeter length, if this is 4 centimeter length, that means length is double, but both are copper. So, if you observe, if you measure the resistance, we know now how to measure the resistance because we have learned Ohm's law. Using Ohm's law, we can measure. So, in the Ohm's law circuit include L length of copper wire and 2L length of copper wire. You can find that the 2L length of copper wire will have double resistance. If this is having R as resistance, this will have 2R. The resistance will get doubled. So when the length is doubled, resistance also doubled. And the same length copper wire, if you have an area cross section A and the same length, keeping length the same, but area cross section will be doubled. Length is both wire having length L, area cross section is doubled. So what are the conditions? The first case, length is doubled. The second case, we have kept the length the same, but the area of cross section is doubled. That means initially if it was A, now you have changed it to 2 times A. The area is doubled. In this case, if initially if it is resistance, if it is R, then the resistance will become R by 2. What is the meaning? When the area of cross section is doubled, resistance got reduced. So now we can bring out 2 factors that measures resistance of a wire. What are the 2 factors? One is length, another one is area of cross section. So here, when you change the area of cross section, make sure that the length remains same. So comparing these 2 factors, we can say that resistance of a wire is directly proportional to length. About this variation, I have already explained you something which is increasing in proportion to the other quantity. We can call it as a direct proportionality. So since L increases, R also increases. Therefore, we can write R proportional to L. And as the area cross section is increasing, resistance is getting reduced. Therefore, we can have an inverse proportionality for the area of cross section. So what is the meaning? As length increases, resistance increases. Area of cross section increases, resistance decreases. So R is proportional to L by A. For L, it is a direct proportionality. For area cross section, it is an inverse proportionality. Now, if you want to change this to an equal sign and to get an equation, we can change this to equal sign. And as usual, when you change a proportionality sign to an equal sign, we have to introduce a constant. Here, I am going to write a Greek letter. This letter is pronouncing as rho, R-H-O. R-H-O, rho, a Greek letter. This is the constant of proportionality. And the other two quantities, we can write L by A. Therefore, R is equal to rho L by A. This is an equation for measuring resistance. R is equal to rho L by A, where rho is the constant of proportionality and rho is called as resistivity of the material. So now we have to see what is the difference between this resistance and resistivity. So resistance is the property of a material by virtue of which it opposes the flow of the current through it. So resistivity is equal to resistance when length of the material is unity and area of cross section is also unity. For unit dimensions, the resistivity will be equal to resistance. So we can write R is equal to rho when L is equal to 1 unit and A is also equal to 1 unit. When L is 1 unit and area of cross section is 1 unit, then the resistance is equal to the resistivity. This will give us a definition for the resistivity of the material. How can we define it? So resistivity is the resistance of a material. Resistivity is the resistance offered by a material of unit length and unit area of cross section. Did you understand? So if you take 5 meter length of copper wire, 5 meter length we have to talk it as resistance of copper wire. But on the other side, if we take 1 meter and 1 meter square area of cross section, that is a unit dimension, or 1 centimeter length and 1 centimeter square area of cross section of that particular material, then how much resistance that unit dimension possesses, that is called as its resistivity. So resistivity is the resistance offered by any material of unit length and unit area of cross section. Therefore, resistivity for a particular material will remain as constant. If you take any length, suppose if the length varies, so if you increase or decrease the length of the wire, resistivity will not change. But what will change? Resistance will change. If you change the area of cross section of the material, resistivity will not change, but the resistance will change. Why the resistivity will not change? Because resistivity by its property, it is for unit dimensions of that particular material. It will not change with respect to the change in dimensions of that particular material. So resistivity will remain constant. But material to material, the resistivity will change. Copper will have a particular value of resistivity. silver will have another value of resistivity and aluminum will have another value of resistivity, but resistance of copper can vary with its length or area of cross section, but resistivity will not vary. So the factors affecting resistance are L and A. L is length and A is area of cross section. The unit for measuring resistance, we learned that it is, can anybody say? Yes, it is ohm. And now what can be the unit for resistivity? So we can make a unit for resistivity. So from this equation we can write rho is equal to R cross multiply R A by L. Rho is equal to R A by L. Now if you take R A by L, the unit for area of cross section is meter square. Yes. And unit for length is meter. Unit for resistance is ohm. Therefore, what will be the unit for resistivity? Resistivity can be measured in terms of ohm meter. So this is a symbol for ohm, and resistivity, the unit which we can use to measure resistivity is ohm meter. So whereas resistance, the unit for resistance is ohm, resistivity will be ohm meter. So finally, what is the definition for resistivity of a material? Yes, resistivity is the resistance offered by any material of unit length and unit area of cross section. So whether resistivity will vary with length, your answer must be no. Whether it will change with area of cross section, again your answer must be no. Then what factors can alter resistivity? One important factor is the nature of the material. Nature of the material. According to the nature means when material changes, the resistivity will also change. And another factor is temperature. So that is why when we defined or when we have given the statement for the Ohm's law, we have put one condition there, under constant physical conditions. So why we have mentioned it is because when the temperature of the material changes, so when we verify Ohm's law, if the temperature of the material changes due to some reasons, then what will happen? The resistivity itself will get changed. So another factor which can alter resistivity is temperature of the material. Detail of this particular quantity and its variation and how does it make the resistivity of a material to change, this you will study in higher class. 10th standard, just to keep in mind that resistivity can alter with respect to the nature of the material as well as the temperature under which that resistivity is, a resistance wire is kept. So if the temperature alters, the resistivity can alter, hence the resistance also. When the resistivity changes, resistance also will change. So these are the two factors which can alter the resistance of a resistivity of a material. But what are the two factors which can change the resistance? It is length and area cross section. So I hope you understood. So always children will get confusion between resistance and resistivity. So if I ask you a question, a wire of length L is doubled its length to 2L, double the length. So what will happen to the resistivity? What answer will you give? Resistivity will not change with respect to length. Resistivity will remain constant, whereas resistance will get a doubled. So when we solve numerical problems, this particular concept you have to keep in mind, that resistance can alter with respect to length, but resistivity will not. So the next class onwards, so we will solve numerical problems based on this equation and the previous classes equations. 3 small equations you have studied. What are they? Let us recall the first equation. What you have learned is I is equal to Q by T. I is equal to Q by T, first equation, and potential difference V is equal to W by Q, and Ohm's law V is equal to IR. Now we have learned this equation rho as RA by L, or R is equal to rho L by A. So what is the unit for resistivity? Resistivity unit is ohm meter and the resistance unit is ohm. So these 3 equations, 1, 2, 3 and the new equation, study well and be prepared for solving the numerical problems.